If you've ever been to the Grand Canyon, I bet you shouted "hello" into the canyon to see if you could hear your echo. If you did, you were rewarded with a series of hello responses. An echo happens because the sound waves generated from your shout hit the hard walls of the canyon and get reflected back toward your ears. The same thing would happen if you shouted "hello" into a wall. However, canyons are more fun because the many rocky surfaces within a canyon cause the sound waves to bounce multiple times, multiplying the number of hellos you get back. Sound waves do not only interact with objects, they also interact with other sound waves. In this lesson, we will take a look at the different ways sound waves interact with each other. We see from our example of an echo that sound waves are reflected when they hit a solid object. However, when sound waves hit each other, they do not get reflected. Instead, they blend together. Sound wave interference is the term used to describe the result that happens when sound waves collide. How this interaction affects the waves depends on how the waves meet. If the colliding waves line up in a complementary way, then they strengthen each other, creating a new and more intense wave. This type of sound wave interference is referred to as constructive interference. In other words, sound waves that are of equal frequency and phase add together to form a wave of larger amplitude. As you may recall, frequency refers to the rate at which the waves occur, or more specifically, the number of complete oscillations per unit of time, whereas amplitude refers to the height of the waves. The higher amplitude of the new wave will sound louder to you. Sound waves do not always meet up in a way that complements each other. Sometimes the waves are completely out of sync and end up creating a new and less intense wave. This type of sound wave interference is referred to as destructive interference. In this case, sound waves that are out of phase cancel each other to form a wave of lower or no amplitude. This will sound quiet, or if the wave is completely canceled, you will hear nothing but silence. In fact, this is how noise-canceling headphones work. The headphones are equipped with a small microphone that picks up noise from your surroundings. Electronics within the headphones create a sound wave that is completely out of phase with the surrounding noise. This results in silence. We also see destructive interference at work in undesired places, like theaters. When multiple speakers are in use within a closed auditorium, the sound waves can interfere with one another. If the sound waves cancel each other, they result in dead spots, or areas where little or no sound is heard. People sitting in a dead spot area would have a lot of difficulty hearing the show. Up to this point, we have discussed colliding sound waves that have the same frequency and similar amplitudes. But what happens if the frequencies of the two waves are different? In other words, what happens when one wave is moving faster than the other wave? The answer is that you hear beating. When two sound waves with different frequencies line up, part of the wave interferes constructively and part interferes destructively. This produces alternating soft and loud sounds, known as beating. When you hire a piano tuner to tune your piano, he will use this phenomenon to do his job. The worker simultaneously strikes a tuning fork and a piano key. The frequency at which the tuning fork vibrates is known. If he hears a beat, then he knows the piano is out of tune. Let's review. The term sound wave interference is used to describe the results that happen when sound waves collide. Constructive interference describes what happens when sound waves that are of equal frequency and phase add together to form a wave of larger amplitude. Destructive interference describes what happens when sound waves that are out of phase cancel each other to form a wave of lower or no amplitude. We see destructive interference at work with noise-canceling headphones as well as dead spots in theaters, which are areas where little or no sound is heard. When sound waves of different frequencies collide, the result is beating, because part of the wave interferes constructively and part interferes destructively.